Okay. So for lists, you can basically make like lists of different things. Like for example, this first list here is like odd numbers. This one is just some animals. So they can be like, you basically define them using square brackets and separate each item with commas. So like the very first list is a list of integers, and this one is a list of strings. But they can also have multiple data types, like numbers, strings, whatever else you want in there. And there's different ways to like index lists, so basically find the value. So like let's say we want something at, like we want the first thing in our list. So one of the main things that comes up with most coding languages is that lists, the first position start at 0. So like if I wanted the very first thing of my animal, so I wanted dog, over here I would just put 0. And I know there's like a lot of stuff here, but this is what it prints out, dog here. And then you can also use like len, and then in parentheses you put the name of your list to find the length of your list. So those are like the major things with lists that you, like the main thing I would remember is that the index of the first item is at 0 and not 1. And if you're an aerospace major, you'll probably be using MATLAB, where like for lists and matrices, they start at 1 actually. So it's just important to remember that difference. So yeah, and then there's also some other examples here of like how to add and remove items from a list, so you can go over that more later. Those aren't like super important right now. We also went over dictionaries, which are kind of similar to lists, except it's like there's 2 values in every item. So there's a key there's a key and then there's a value assigned to that. So for example, this dictionary is like animals and then their corresponding class, like their value. And then there's like different ways to get the value from your key. Like you just say the dictionary name and then your key. And then you can also add new values. So these are used for like storing a lot of information. Trying to think of a good example. Like, for example, if you had like a bank account or some kind of account, a website could use like your key could be like your name, and then the value could be a list. So like I said, you could have lists with different data types. So you can have a list that stores like your birthday, your email, things like that, for each like user or something like that. So that's what dictionaries are usually used for, and they're pretty useful. Okay, and then we also went over loops. So there's a few different types of loops. The main 2 types are like for and while loops. So for loops are usually, you usually use them either with lists if you're trying to do something for each item in a list. So this one does it for each item in animals. It just prints it out. So I think that's what's right here. And you can also do something a specific number of times. So if I say for j in range 10, it basically creates a list that goes from 0 to 9. So it doesn't include 10. And then it just prints hello out 10 times. And then while loops are a little bit different. So let me move this. Okay, so while loops let you, like they basically repeat until a certain condition is false. So like, I think from the very first workshop, we did an example where we enter in a password and it basically tells you if the password is wrong or right. But this has like a loop in it. So it's basically saying, while the entered password is not equal to like the actual password, then it's going to just like ask you for input. So it's going to keep repeating. So let me rerun this. So it says like, what is the password here? So the actual one is 1, 2, 3, 4. So if I type in like something random, it's just going to keep asking me until I type in 1, 2, 3, 4. and now it like moves on. So that's what while loops are used for. You just have to be careful because you can get stuck in like infinite loop with while loops. So that's just something to check. Like as long as that condition here eventually becomes false. Okay. All right, and then towards the end we went over functions, so I'll focus on that today. Well, okay, so far I know that was like a really, really quick run through of like all of last time, but do you guys have any questions right now?
For the range,
Yeah.
like you had J and K. What were those like variables or?
Yeah, so those are just variables. I could also like, so you don't necessarily have to use them inside the loop, but you could. So it basically, it's almost the same as this where it goes through each item in my list, except range creates a new list and it just like, that's why I typed it out here. So it just looks like that. It just doesn't show up. So basically what J is, it's just like for each item in range. So yeah, this like word here or variable can be anything. I just put it as item right here just for like clarity, but usually you use like IJK. That's what you see most of the time. So yeah,
Okay.
it's just a variable. But like, yeah, for example, if I did a print J in there, it would, yeah, so it prints J and then it prints hello and then it does one, hello, and so on. Yeah.
Okay. Thank you.
Yeah, yeah, no problem. Anything else? All right. Yeah, and if questions pop up, just like let me know. Okay, so functions are, how do I put it? So functions are basically used when you have like repetitive code. Um, so like for example, if you're coding a game, right? So every time a player, um, like like a simple game like tic-tac-toe, every time a player puts down like a piece, right? You have to check if they have three in a row. So like every single time they do that, you're gonna check. Um, and that's pretty repetitive. So what you could do is create a function that has like basically all the code for like checking if a player won, and all you have to do is like call that function when you need it. So you don't need to like type it out every single time. And you would probably put it in a loop anyways, but it's still good practice to like organize your code into functions so that it's like easier to read and you know what's going on, stuff like that. So this very first function, so this part is kind of just a like overview of what functions look like. Obviously, like if you just wanted to print hi, you probably wouldn't need to write a function. But what I'm gonna do is let me comment this part out for now. So I have like this part that says like def greeting. So this means I'm like the def part just means I'm defining my function and greeting is the name of my function. And then I have parentheses here, which right now is empty, but we'll get to that later. And then you put a colon, enter, and then whatever you want your function to do. So if I try to run this right now, just type in that. Okay, so this is from before, but it doesn't print hi anywhere. So what we actually have to do is like you define your function, but it doesn't do anything until you call it. So right here is our function call. So you just put the name of your function and then anything that's supposed to go inside the parentheses will go there. And when I call my function, it prints out hi. So that's like a very simple example. You probably wouldn't want a function for that, but okay. So you can also have in the parentheses, we have what are called parameters or any input that you need into your function. So if you have like a simple example would be if you're doing like a math operation, like adding two numbers. Again, you probably wouldn't need a function for this because it's like really simple. You just add like A and B, but just as an example, you would need input for like A and B, right? So you add them in here as parameters, and then in your code, you kind of just pretend like they're the numbers that they're supposed to be, or like that you'll use later. So I just say like sum equals A plus B, and then I'm going to change this to print sum right now, just for a second. And then I'm just going to call this function. So now when I call it, I should actually, like, this pops up, right? So I'm going to input the numbers that I want for A and B. So I'll just do like, oops, those are the same number. Okay. And now when I run it, it'll just basically, it sets A to 23 and B to 40. Then it just does what's in this function. And it adds them together, and then here it says to print them out. So far, does that make sense for like functions and parameters?
Yeah.
Yeah. Right. Okay. And then, okay. So I'm going to change this back to return, and I'll explain what that means. So a lot of time in functions, you use a return instead of a print, because return, it basically doesn't print it out, because usually like in programs and stuff, you don't really see the console. This is more to just like help you test out your code. So it lets you store values to variables, because when you print something, it just goes to the console and then it prints it out there. But then if I like later on in my code, if I was like, oh, what's 3 plus 10? I forgot. Then I'd have to run this again. But I can just instead make a variable and set it to like add 3 and 10. And since it's a return, it'll basically set this variable to like the result, like whatever this function returns. So it'll set it to 13. So now when I run this, it has 13. And then this other number, it's like I added 342 and 443. And then it's like, for example, later in my code, if I wanted to multiply sum 1 and sum 2, I already have them stored. So I just have to multiply those two numbers, because they're already stored in variables. So that's kind of the point of a return. And also it's good if you don't want to like print anything to your console, but you still want to just store the information somewhere, for maybe even to print later. Yeah, okay. And then this last example that I did was just like kind of more realistic one, like the Pythagorean theorem. It's not like a super long equation, but you probably wouldn't want to type it out like every time you need to use it if it was a lot. So you just have like your A and B and you're finding C. And if I run it, like it returns these, so I'm setting it to a variable, and then I'm printing out that variable. So do returns make sense, or do you guys have any questions about that?
I think I get it. So you just put return to any variable, or can you do things other than variables?
Like
And then it'll
returning
spit it
stuff?
back. Yeah.
Yeah, so like it depends. It's a little bit weird in Python. Like in Java, when you make functions, or I think Java and C, or when you make functions, you usually define a return type. So you say like, oh, this function is going to return an integer, or this is going to return a string. So yeah, I could like return any. Usually it's a variable, but I could also put like return, like if I wanted to put a string here, then it would just return the string. Yeah, so it's like whatever comes after the return will like kind of be the output of your function.
Okay.
Just, yeah, did that help clarify it?
Yeah. Yeah, it did.
Okay, all right. So basically, before we like move on to new stuff, so there's like this website, oops, called CodingBat, and it has problems in Java and Python. But obviously, we'll be doing Python ones. So I'd really like recommend that you guys check it out and maybe just start up with like the level one ones, like they say like what the categories are. So the warm-up ones are usually really short. Uh, String and list ones are pretty similar, and the logic ones are like if else um, types of things. So it's just like good practice, but they use functions, which is why I wanted to teach that first. So let me just, I don't know. Here, let's just do this one. And they also, some of them also have solutions, which is nice. Okay, so basically it gives you a description. So given two int values, which are your, like here they define like a function, and you're supposed to write like the actual definition of it. And you have two parameters, so a and b. You want to return their sum, but if they're the same number, then you return double their sum. So it gives some examples too. So like if a equals 1 and b equals 2, then it would return 3 because it's just returning their sum. But like if it's 2 and 2, then you return like 2 times their sum. Yeah, okay. So do either of you have any idea of like how you might get this started? If not, it's all right, but just wanted to give you guys a chance to think about it first.
Wouldn't you start with an if, yeah, A and B not equal, or you can do equal first.
Yeah.
But if A and B are not equal, then
Oh yeah, so yeah, CodingBat uses returns, which is also why I was teaching that.
okay.
So
So
yeah,
then wouldn't it
return.
be return so here would you put in a variable and then set that variable equal to A plus B, or
Yeah, so you could do that. Like one way to do it is do like C equals A plus B and then you return C, but the easier way is just to do like return A plus B.
okay.
Yeah, and you don't need to even like put that in parentheses or anything. It'll just, everything after the return, it'll just kind of calculate that. Yeah, so
All
since our
right.
first condition is not equal, then our second one would just be like else, because if it's not equal, or if it's not equal, then it would means it's equal to each other. So here I would just say return. I'll just do double their sum. I guess that would just be 4 times it, but yeah. And then once you have your code, so yeah, you can have multiple return statements, but only one of these. Also, is this like really small? Okay, only one of these are gonna actually like return, depending on what your parameters are. So now if I click go, yeah, and it does some test cases, and then it just as long as they all match like what they're supposed to output, then it says like all correct.
So is it not picky in regards to the exact code as long as it spits out the end result?
Yeah, yeah. So as long as the results are correct, then it works. And if you click on solution, it checks. So like they do it a different way in the solution. So first they make a variable called sum, and it just adds them together. And if it's double, then it sets sum to double itself, if that makes sense. And then it just
Mm,
returns sum at the end. Yeah, that's
okay.
also another way to do it. So there's like always with code, there's always so many ways to do it. So like yeah, this is like a good start if you're just trying to uh, get used to like the syntax, like how to code, like it, what's it called? Usually you can figure out how to do it, but it's hard to like remember what all the syntax is to like actually code it. So it'll just help you like practice that and get used to like Python as a language.
Okay.
Yeah, and then they're usually like just functions like this. So I would just start off with like the warm-ups, and yeah, they explain them and they give examples. So you just read through those. Yeah, so any questions about, oh, and also you can like make an account so it'll actually save your stuff. Like I'm not logged into mine right now, but yeah, it's like nice because then you can see your progress and stuff. All right, so any questions about this website? All right, cool. So I'm gonna make a new one. Okay, so basically what we'll do for the rest of the time is go over classes and objects. So it's kind of like an intro to object-oriented programming. Usually Python isn't used for like object-oriented stuff. That's usually Java, but it does have like objects that you can create. So before we get started on like actually coding anything, I'll stop sharing for a second. Okay, so basically like, actually this might be easier to draw. Let me see if I can, wait, oh, okay. Can you guys see that?
Is it
It's
the
loading, but
big buffing?
So.
Wait, what?
Is it loading for you?
Yeah, it's loading. Oh, yeah, we can see it.
Okay, yeah.
Okay. Yeah, okay. So basically you can create like what's called a class in code, and you can have like for each one you can have a subclass, and objects are basically like specific instances of that class. So basically like if I draw it out with the example of animals, for example. So like your overall class would be like your, sorry, I'm drawing with my finger. It's not very good. Okay, you have your animals. And then within that, you can have different subclasses. So like you have your mammals, reptiles, amphibians. Okay, yeah, it doesn't really matter. You just have like whatever. I forgot how many there are. And then each of those can have their own subclasses. So you can have like dog, human, so on. And each of these can have their own. And the list kind of just keeps going down. It gets like more, the parameters for each one get like narrower. So like, for example, each kind of level or each class has its own properties. So you can say all animals are living things, and that means that all mammals are living things and all dogs and humans are living things. But for example, one like more unique property of mammals is that they have fur or hair or whatever. So like mammals would like have that property that like that has hair, but that doesn't mean that animals would or reptiles or amphibians do. But that means that everything below mammals does. So dog, human has it. And then so basically as you get down like into the subclasses, the properties get more narrow. Also, just as a note, you also sometimes call like the upper class the parent class and below is the child class. So if I say that, that's what I'm talking about. And what I mentioned with objects is that once you define these classes, so like I can say that I could define a class called mammal and say that all mammals have fur and I don't know, like maybe like you can have other properties that aren't necessarily unique to mammals. So it can be like area of the world they're from, something like that, and you can define those later when you create an object. So when you create an object, you define like what like specifically about that, like the properties of that mammal. So like what area of the world they're from. Like for example, if you create an instance of a dog, you could give it a name, you could give it a breed, say if it's like a pet, things like that. So it's like this class dog is more like abstract, and then when you create an object of that class, you're like defining it. It actually almost becomes like a variable. So does that kind of like generally make sense? Like the idea of classes and objects?
Yeah.
Yeah.
Okay. So let me stop that. And yeah, let me get Replit back. Okay. All right, so I'll kind of use the same, one second. Okay, I'll kind of use the same example with animals to create this. So instead of starting off with like the animal class, I'll just start off with mammal as my top one. So the way that you define a class is you just type class and then the name of your class. So I'll call it just mammal. And then you just do like parentheses, colon, and then enter. Also, let me know if I need to slow down or anything. And if you have questions, just unmute. Okay. And you also want to initialize your class. So this is basically like properties that this class has. So we do def, which is just define, and then 2 underscores init, which means initialize, and then 2 more underscores. So this is like a built-in function with Python, and we do parentheses after. And then we're going to do, it's going to have parameters in here. So the first one is always going to be self. And that's just saying like what you're initializing, which is like this class. So that's why it says self. So self, and then we'll say mammal. We can just do like location and a sound, like sound they make. And we'll do one more for fun. So age of this mammal. Or actually, we can do lifespan. Yeah. Oh, and then name would also be a good one. Okay, I'll get rid of like location maybe, just to simplify it. And then the way that we define it is we just do like self.name equals name, self.sound equals sound, and self.lifespan equals lifespan. And what this does is it basically like later when you create an object, like let's say I create an object called X, and X is a mammal. If I do like x.name, we want it to like go and get the name of the mammal. So that's why we're doing this. It'll be a little bit different defining it, but we'll get to that a little bit later. So this is just the initialization, and then next we can also, or actually let's define a mammal right now. So it's like a variable, so you can call it whatever you want. Yeah, I'll just go with X for now because I can't really think of what else to do. But you do X or your variable name, and then you say like the name of your class, and then you do parentheses, and then it pops up like with what parameters it needs. So I'm gonna give this a name, or I guess I'll just make this species instead because that makes more sense. Okay, so I'll give it species. So I just want to make sure that these are all strings because, or these two at least are strings. I don't know like specific species names, but I'll just say dog. And then a sound is bark. I don't know what the lifespan of a dog is. I think it's like 10 years or something, right? Okay, so we'll just say that that's like our mammal. And now I can like get stuff out of it. So if I say print x dot name, or it's not name, species, then it'll just print it out. So far that's like not super special yet, but you can also define like specific functions that only like mammals can do. So if I do like def, and I'm doing this inside my class, so I'm doing like define a function called make sound, and it's just gonna say the sound twice, I guess. And so now if I do like x dot and then I just put the name of my function, oh yeah, so I'm using sound inside my function, so I need to make sure I do self dot, because what it's going to do is that when I call it here with x, it's going to replace self with x, so it gets the sound that x makes instead of some other mammal. So now when I run this, what's the issue? Oh, right, yeah. When you write functions in classes, you always need to add self as the first thing. Yeah, so it just barks twice. So far, does that make sense with class, or like how to make a class and then make an object? Like this is an object.
Yeah.
Okay. All right. So with like this is pretty simple, but with that you can make subclasses. So let's make one called human. So this is going to be a subclass of mammal. Okay, so it's almost the same definition, except here I'm going to put the parent class inside the parentheses. So I'm going to just put mammal in there. So it's just saying like a human is a mammal. And then everything else is almost the same. You can like basically copy over these parameters and also add more. So I'm going to do the def and then two underscores in self. I'll give them a name and location. And then here I'm just going to do the same thing and define each of these things. And you guys can use your own examples too. It's up to you. Okay, and now I can create a human. So I'll just make it y equals human. I'll just make myself. So Nikita, honey, and I'll just put Massachusetts. So here I can also make like a function in here. And like I can define it, so if I want to, I can just use like hi, I'm blank. I'll just do this for now. Oh yeah, and then again, remember to put in self as a parameter. So now if I want to do like y dot greeting, I'll just like say hi, I'm Nikita. Something important to note, if I tried to do like x dot greeting, it would give me an error because a mammal is not a human. Like a human is a mammal, but not the other way around. And if I tried to do y dot make sound, that also wouldn't work just because I don't have a parameter here called sound. So if I wanted to, I could add like species, sound, lifespan to my parameters, and then it would like let me use this function here. Just because a human is also a mammal, so technically it has like, this is called inheritance, so it like inherits its functions. But you need to like specifically define them again. So far, any questions about that? All right. So that was kind of like a brief intro to object-oriented programming. Like I said, you don't really use it in Python as much, but I know that like Java is like all object-oriented, and so is C, I think, which I think is like the next session's programming workshops. So it's pretty useful to know like kind of the basics of like how it works. But just as a general idea, basically classes are more of an abstract idea, and then you have like functions within those classes, and you can make objects, like define them and make them use those functions. Yeah. All right, so kind of, I'm gonna stop sharing just for a bit. So kind of the thing that we're leading into next for like next week, starting next week, is going to be Python packages, mainly Tkinter. Have either of you guys heard of that before?
No.
I haven't.
Okay, so first so Python packages are basically like you can import a bunch of functions that have already been made using Python so that you don't have to like write these yourself, and then they'll let you do like more advanced things. So one big one that a lot of people use is Numpy. So I can kind of show you what that looks like. So Numpy is like, it's a math one, and it lets you do matrices basically. So let's find something. Like you can do arrays like this. I don't know. Let me. Oh yeah. Okay. So this one is like, it looks like a two-dimensional one. So, or I guess this one is a three-dimensional one. So you can make like 2D, 3D arrays, which are basically like matrices. And they come with all these functions like reshape or shape, things like that. So basically, if you were ever like using MATLAB for a class, that's why they'll usually tell you that you can use Python if you want, because you can technically do it this way. So it's like just a package that you import, like at the very top of your program. If you just say like import Numpy, then it'll import all of these functions and stuff. So Tkinter is kind of like that, except it's for GUIs, and GUIs are graphical user interfaces. And the plan is for next year to make a ground station for our rocket, which we'll probably be using like Python and Tkinter for that. So just kind of wanted to give an intro so that we can actually like use this next year. So let me go back. And so the way that we use, since we're using Replit, it's a little bit different. If I wanted to use Tkinter, I would actually put it in as my language. You'll notice that it's still in Python, like the logo is still Python, because it's like our language is still Python. We're just using this package. And then, okay, I'll just leave it named as that for now. And I click create. Okay, and it kind of gives us like a little starter program. So at the very top, it says import Tkinter as TK. This is basically because every time we use this package, we're going to have to do like Tkinter dot and then the function that we want to use, which would be like kind of annoying. If you remember, we had like math.py. But imagine if math, like the word math, instead of math, it was called like mathematics. So that would be like really annoying to type out every single time you needed to get something from that package. So if you just say as TK, it's gonna like kind of rename Tkinter to TK instead. So that every time you need to say Tkinter, you just use that instead. And basically, like when I run this little thing, it'll kind of show up as a little screen. So since Tkinter is like a user interface kind of thing, that's why it pops up in a separate screen. So we still have a console that we can print to if we wanted, but the main thing we're going to be like using, I guess, is this little window. You can see they spelled world wrong. And it basically pops up. You can make like buttons. If I exit out of this, it'll quit my program. If I click this, it doesn't really do anything, but you can basically, you can code it to do stuff. And you can define like different things. Like the first thing they do is like create a window. So that's just like the TK thing. You add a title to the window. So that's like, if it was a pop-out window, it would be like the thing on the, what's it called? On the bar at the top. And then you can define like how many pixels it is. So this one's a pretty small one. And I can also like move this around in this little screen here. Oh, it's getting messed up. All right. And then it creates a label. So it puts that right there. We can also define like where we want it to go. But right now it's just like in the center right at the top. And then next we have a button that just says click me. Like if I wanted to make another button, I could just stop running this. And I'll just call this one button 2. Okay. And now if I run this, it just puts it like right under, like the pack just puts it like right under this other one. So now if I like try to click on them, it makes a little clicking motion. So this is kind of where we're heading. If you want something that's like more, I guess, like applicable to like generic engineering stuff, or even like just learning basics of MATLAB, you could even start with like Numpy if you want to try playing around with that. And I know this article, like this website is pretty good. This is where I learned it. So it like shows you different types of things that you can use with it if you want to learn that. But yeah, did you have any questions about, I know I didn't show you much, but you can basically, if you want, you can just make a file with Tkinter and just have it like this. And we'll actually get started like working on it next time. So Yeah, but did you have any questions with that or anything that we talked about today?
How are you guys planning to use Tkinter for Rocket, the launch pad next year?
Yeah, so I'm guessing it would be like we'd have a laptop at the ground station and it would kind of like we'd be able to see like the data about the rocket. I know someone was saying something about like um, actually seeing like the position of the rocket. So we have like a rocket on our screen like that looks like ours and it kind of shows like its position, any other data. I'm honestly not entirely sure. I probably personally would not be working on it. But I know that's just something that like Max was saying that we would be able to use for it. So, because usually on the team we use for programming like the payload and stuff, we usually use C and C++. But the main reason we're teaching Python is because it's like a good intro to programming, and then also because Tkinter is pretty useful. Yeah. Anything else? All right, cool. So that's kind of it for today. I would keep working on coding bat. Like it's definitely like super, super helpful and just getting used to like actually applying the things that we learned. And you can also just do it with like your notes or even like the files that I send afterwards. If you want to have those open to kind of check back on like how to do stuff, then you can do that too, and you'll just like get more used to it over time. Like really the best way to learn is just to practice. So yeah, and then next time we'll actually get started with Tkinter and creating like some kind of um, GUI with like buttons and stuff. So yeah, I'm gonna stop recording.